This is a set of example solutions for the scientific notation problem set from SciencePrimer.com. The format of all the questions in this problem set are the same. You're asked to write a number, you're given a number in standard formation and asked to write it in scientific notation. So I'm going to go through a set of numbers of different sizes. The first one we're going to do here is 2,680. We'll go through this one in a little bit of detail, and the steps we follow here are the steps we'll use for all of the subsequent problems. So the first step is to write the number as a decimal fraction. With one digit to the left of the decimal place. So we have one digit to the left of the decimal place. In this case it's a 2. We'll write the decimal place and then a 6 and an 8. Step 2, add times 10 to that decimal fraction. So 2.68 times 10. And now what we need to do is figure out what goes here, what exponent 10 is raised to. The third step here is to count the number of places the decimal moved from the original number to the one-digit decimal fraction. And so all we do is we have the decimal started just after the 0. We put it after the 2 and just count the places. 1, 2, 3, 1, 2, 3 places. So the number here is 3. And then that 3 is what we put in here. So 4 is to raise 10 to that power. And so then we just have the complete answer, 2.68 times 10 to the 3. Or, now remember, if you're working with computer rather than, it's not easy to put this exponent in, you can also write this as 2.68e3. And this is an acceptable format and what you'll need to use when working with a computer. Okay, before we go on to another example, I want to just explore this one a little bit more and just ask the question, how can we check that 2.68 times 10 to the negative 3 actually equals 2,680? The way we can do that is just to remember that what this means is 2.68 times 10 raised to the third power. And what this means is 10 times itself 3 times. So 10 times 10 times 10. Another way to think about that is that it's just 2.68 multiplied by 10 3 times. So let's check that. We can multiply 2.68 times 10, and this will give us 26.8. We can go back and say this 26.8 times 10 equals 268, and then we can just do it a third time. 268 times 10 equals 2,680. And so we got back to the original number just by following this 2.68 times 10 3 times, or 10 times 10 times 10 times 10 times 2.68 will give us the original number. Another little trick as you're getting comfortable with this, if you have access to a calculator, most calculators will take relatively small numbers if you put them in scientific notation and convert them back out. So we can go ahead and take 2.68, and to raise the exponent we use this EE button on the calculator, EE, and we'll make it 3. So this is our number, 2.68E3. What does that equal? 2,680. So you can use your calculator to check your understanding of these, particularly for smaller numbers, where the calculators default to standard notation even if you put them in as scientific notation. Okay, now let's look at a problem where the value is less than 1, which means the exponent 10 will be raised to will be a negative number. Follow the same steps. The first step is to write the decimal fraction, putting it here, 3.54. The second step is to add times 10. Since this number is less than 1, the exponent is going to be negative. Now let's count the places we had to move the decimal. 1, 2. So this number is 2, so it's 3.54 times 10 to the negative 2, or if working with computers, 3.4e minus 2. And this is the number you'd put in. Now the difference between this last problem, where we checked it this way, is that if the exponent is negative, that means we're dividing by 10. So in this case, what we're saying is we're taking 3.54 and dividing by 10 2 times to get from the scientific notation format back to the original number. And we can check this. First division by 10, 3.54 divided by 10 equals 0.354. Do it a second time. 0.354 divided by 10 will equal 0.0354. And so we've gone back just by dividing this number, the decimal fraction, by 10 2 times, we've gotten back to the original number. Let's do a couple more problems. Now we're looking at much bigger and much smaller problems, but the process is exactly the same. We're going to make this a single digit decimal fraction, 7 decimal place 9 4, add times 10. And since this number is greater than 1, this sign is going to be a positive. And let's count the number of places a decimal place moved. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we've moved this 13 places. So this is a 13. Or in computer format, 7.94E13. So that's the answer. Again, a much smaller number, lots of zeros, difficult to write. In scientific notation, we just make the decimal fraction, 6.28 times 10. We're less than 1, so it's a negative number. Count the number of places the decimal had to move. 1, 2, 3, 4, 5, 6, 7, 8. So the decimal place had to move 8 times, so it's 6.28 times 10 to the negative 8, or again, 6.28 e minus 8. This completes the demonstration. A link to the problem set can be found in the description of the video. Please feel free to contact me if you have any questions.